So I talked about PV cells, I talked about PV module, and then PV array. So PV cells are just the cells. You know, when you look at your panel, your module, your PV module, you will see that it's a combination of cells. Some of them is 60, 72, depending if it is a half cut, but we're going to come to that. You know, depending on the structure and the arrangement of the cells, you can have more, you can have less. So it depends, but you know, a combination of the cells is what we actually know as PV module. And then when you have a combination of the module, we have what we call the PV array. So the modules are formed by connecting PV cells in series or in parallel and encasing them in a protective material. PV modules can be connected in series and they can also be connected in parallel in order to form a PV array. The number of modules determine the maximum power generation capacity of the PV plant. Now, I talked about half cuts and why do we have half cuts? When you also go to the market, I'm bringing out this concept so that when you go to the market and you begin to see some of these terminologies, you can actually understand what they mean, and and you'll be able to advise on which is a better option, depending on the financial disposition or the financial outlay of your clients or whoever is financing the project, right? So remember when I talked about polycrystalline and monocrystalline, and I told you that monocrystalline, at the edge of it, there's a cut at the end of the squares, right? Whereas polycrystalline, you don't have that. So it's one of the ways to identify monocrystalline and polycrystalline. Then we also have a half cut. But yes, I've seen sites where it is being used in Nigeria. I'll just brush over the major differences. Now, for the polycrystalline, it has a lower efficiency. The polycrystalline PV module, it has a lower efficiency and is relatively cheaper, or it costs less than the monocrystalline, because the monocrystalline has a higher efficiency. And how you will identify this monocrystalline is, I don't know if I can zoom this. Okay, so you notice that at the edge of the square, at the edge of sorry, is this zoomed from your end as well?
Yes, sir.
Yes. Yes.
Okay.
Yes.
Okay. I just want to know if it's also across or just on my screen. So you can see that at the end of the square, it's at the edge of it. It's kind of cut, at the end of it, right? Unlike the polycrystalline, it's just a fully blocked out square, right? But for the monocrystalline, you will see that it is cut at the end of. So when you see them, you just know it is a monocrystalline. And for most of the monocrystalline, they're darker in color than the polycrystalline most times. Okay, so you can identify when you use monocrystalline and then the polycrystalline. Then the thin film is. Sorry, is anyone asking a question?
No, sorry, no.
So, okay. The thin film solar panels are dark. However, they have a better application in areas where you have high weather temperature. Let us come back to the orientation and inclination angle. I think I'll be very brief about it so that I can round up. So the PV module's orientation and inclination, when we talk about inclination, we're also talking about the tilt angle. So for most of us, we're already used to tilt angle. It's the same thing as inclination. So both the orientation and inclination affect the amount of irradiation that the surface receives, and hence the amount of energy that the module can produce. Now, in the northern hemisphere, when I say northern hemisphere, I don't mean the north, south, east, and west of Nigeria. Now, the entire world is divided at the equator, so between the northern hemisphere and the southern hemisphere. The entire world is divided at the equator. And then you have the northern hemisphere and you have the southern hemisphere. It's different from the north, south, east, and west that we have in Nigeria. Okay. So in the northern hemisphere, the PV module should be facing south. Now, Nigeria is at the northern hemisphere. Remember, I told you that the entire world, okay, one side is the northern hemisphere and the other side is the southern hemisphere. Now, Nigeria is on the northern hemisphere. So for the fact that Nigeria is on the northern hemisphere, PV modules should be facing south. That is how you're going to get the maximum power, from the sun. as long as you're not using tracker. Remember, we're not using tracker, so it's a fixed, installation you're doing. So to get the maximum yield from that your PV system, it is always good that you face south, and that's why if you want to do an installation, it's either you go with compass, or most of these smartphones, they have compass. Just use, and then you can identify where the south is.